All right, we're moving into our next chapter for our trigonometry um, unit. And this chapter is going to be a little bit easier starting off with. When we ended the last chapter, there was a lot to take in. This one's going to kind of narrow stuff down and a little bit easier. So starting off, we're going to make a few notes here. And I just wanted to address the formula for the unit circle. And what we'll need to do is just kind of keep that in mind for the couple weeks to come here. And that equation is x squared plus y squared equals 1. And we'll get into more of that later on in the chapter. Moving forward, we're going to be changing degrees into radians and radians into degrees. Which is fairly simple using a ratio. And that, for changing degrees, we're going to use this ratio of 330 times pi over 180. And we'll just multiply those straight across, and we get 330 pi over 180. Now, what we need to do is just simplify that into lowest terms, and we get 11 over 6 pi. And that is changed from degrees to radians. Now, when we're going backwards and we're going to change from radians to degrees, we're just going to reciprocate that fraction of pi over 180. And we're going to take 2 pi over 3 times 180 over pi. And we're doing that so we can cancel out those pi signs, because if we cross cancel there, we end up with 360 over 3, and we end up with 120 degrees. All right. With this chart, I'll have the chart fully filled out for you in your Google Classroom. A couple things to notice is they're taking all of these degree measures right here, and they're multiplying it by pi over 180. So if you take these different degree measures right here from 0 all the way up to 330, and you just pick a degree and you convert it to a radian measure, you'll end up with all your different radian measures here. So what I'll do is I'll have this chart completed on your Google Classroom. All right, moving now more into calculator functions, we're going to take and evaluate the cosine of 4 pi over 3. So the first thing we're going to do is we're going to convert that to degrees. And that was just taking 180 over pi. And when we do that, we can safely cancel out our pi signs. So when we cancel out our pi signs, we end up with 4 times 180 over 3. And when we do 4 times 180 over 3, we end up with 240 degrees. Okay. Now, in your calculator, just simply type in cosine 240. And you will get negative 0.5 or negative half, negative 1 over 2. And it's that simple. Just make sure you switch that to degrees and then type in cosine of 240. All right, now we're going to be looking at the length of an arc. And we're going to be using this formula right here of S equals the radius times an angle. So what we'll do here first is figure out what do we have here. We have the radius of 5. So we know that R equals 5. All right, and we have a central angle of 128. We have to convert that 128 degrees. And we're going to multiply that times pi over 180. All right, and when we multiply that times pi over 180, we end up with 32 pi over 45. And the reason we did that is because we're going to do another calculator step here. All right. So when we're doing the length of an arc, we're using the radians. So our formula is going to be this. Let's do gray. We're going to say S equals R times that angle. So it's going to be 5 times 32 pi over 45. And you can put this all in a calculator. Once you put all that in your calculator, you're going to get that S equals 11.8. All right. So far, so good. Okay. Let's move to a real world example using S equals R times an angle. So if we notice here, a Winnipeg, Manitoba, Canada, and Dallas, Texas lie along the 97-degree west longitude line. The latitude of Winnipeg is 50 degrees north, and the latitude of Dallas is 33 degrees north. The radius of Earth is about 3960. So there's my R right there. 3960. Okay. Find the approximate distance between the two cities. So what we're going to do is we're going to take and use 17 degrees. And the way I got 17 degrees is I'm going to take 50 and subtract 33 from it. And that gives me 17 degrees. All right. Okay, and the reason behind taking 50 and 33 is because we're using the latitude of both of the cities. All right, so that is going to be my reference angle. Okay, but I'm going to need to convert that into radians. So we're going to take 17 times pi over 180. And I end up with 17 pi over 180. So in our calculator, we're going to type that whole equation in, and that is S equals R, which is 3960, times 17 pi over 180. All right, and that whole part goes in your calculator, and you end up with the solution of 1174.955. I didn't round all the way, so you can kind of see how it works out. Okay, and our last example, we're going to be using area. And when I use the area equation, I like to use 0.5 instead of using that half. It just makes it easier. So I end up with A equals 0.5 times the radius squared times the angle that we need. Okay, so first things first, this is also going to be an all calculator step. So in my calculator, I'm going to type in 0.5 times my radius squared, which is 16, times the radian measurement. And you can leave that in radians. All right, so all of this goes in your calculator. And once you type all of that in, we get that A equals 335.1.